Alright, so we now start our next unit of study. And our next unit of study is going to be on functions. And I know you're going to enjoy this because there's fun in functions. Alright, I get it. So let's kind of talk about the basis of a function. But before we do that, I want to talk about what a relation is. And no, not a relationship, but this is something that you need to know, and this is going to be a little bit of vocabulary words. A relation. A relation is nothing more than a set of ordered pairs. So, for example, I might do this. 1, 2, 3, 4, 5, 6, that's a 5, and 7, 8. Let's say that's my set of ordered pairs. Now, that is a relation. Within a relation, we have, well, let's say within the ordered pairs, you know we have an x and a y in each ordered pair, but there are special names for that. So let's take a look at this again. And again, here was my relation. 1, 2, 3, 4, 5, 6, 7, 8. And we have what's called the domain. And the domain is the set of all x coordinates. So for example, we abbreviate it as D colon, and in here it's going to be all x's, so it's 1, 3, 5, 7. Yeah, that's a little messy. They're not easy to make. So let's try that again. There we go. Then, of course, we have the range. And everyone knows what the range is. It's where the deer and the antelope play. All right. Maybe not. Maybe this range is the set of all y coordinates. In this case, we abbreviate it with an R. And this one is 2, 4, 6, and 8. So that is the range. Now, when I talk about a function, or I should say a let's spell that right. A relation is a function if each element of the domain is paired with exactly one element of the range. Now, if you look back in your notes to the example relation I gave you, you'll find that 1 is paired exactly with 2, 3 is paired only with 4, 5 is paired only with 6, and 7 is paired only with 8. So because of that, that relation is in fact a function. Now, the domain is what we call independent variables. Domains are independent variables because they are the variables that we can do whatever we want. Doesn't matter what happens to them. Where the range, on the other hand, are dependent variables because it depends on what the domain is. If the domain is 1, the range can only be 2, and it's what comes out of it. It's like, you may remember something like this from back in elementary school. they used to have something like this. It was called a function machine, and you dropped a number in and something came out based upon what the function machine did. So if I dropped in 4, out would come 7. But there was no way a function machine could spit out two different things. So if I dropped in 4, it only could spit out 7, because I was adding 3 in this case. That was just a little example for you. Take a look at this. If I list the domain and the range, and let's say I have the domain is 2, 4, 5, and 9. And the range is 1, 3, 4, and 7. And 2 goes to 1, and 4 goes to 3, and 5 goes to 4, and 9 goes to 7. Is this a function? And yes, this is in fact a function, because every x goes to exactly one element of the range. Now look at this. Domain and range, 2, 5, 9, 1, 3, 4, 7. 2 goes to 1 and 2 goes to 3. 5 goes to 4. 9 goes to 7. Is this a function? And you're right, it is not a function. And this is not a function because each number, 2, or the number 2, has been paired with two elements in the range, a 1 and a 3. And in this case, it cannot be a function. One, 2, 3, 4, 2, 5, 8. So when you look at this, is this a function? Well, in this case, this actually is a function. Even though 2 and 3 both go to 5, that's okay. Later on, you'll learn what kind of function this is. But this is a function because every x goes to exactly one y and not to two different ones. But the y's can come from two different areas. That is a possibility. Another way that we can determine if a function is if you have a function, I should say, is what we call the vertical line test. The vertical line test. And in here, what we do is we look at a graph. And it could be very simple like that. And what you actually do is you actually take a line, which I can't get a line right now. Hold on. Let me see if I can get a line here. Okay, so we're going to take a line like so. And I was going to try to move that line, but I don't think I can. Well, there we go. If you move the line across the graph, if the graph only crosses the line, or the line, I should say, only crosses the graph once, then we have then it is a function. So in this case, it's only doing that once, so we do in fact have a function. If we take a look at this graph, like that, and then we draw our line, and then we move our line across the graph, yeah, it seems to be working until I get to this point here. Notice here, it crosses the graph in 2 points. That means one x has two y values, which again is not allowed. Therefore, it fails the vertical line test and is not a function. So, moving on, a function rule. A function rule describes the operations Ooh, let's rewrite that. The operations performed on the domain. So, for example, I showed you the function machine before, but a lot of times I could just simply do it like this. Y equals 2x plus 3. That would be an equation that is a function rule, where x is the domain and y is the range. But sometimes we don't like writing it like that, and we want to write it in what's called function notation. In function notation, we take the y and we replace it with f of x. So we write f of x equals 2x plus 3. And that is the function of x. So it's the function of x, that is f of x, tells me what I'm supposed to do with the x. So let's say, for instance, I say to you, f of x equals 4x minus 7. And I said to you, find f of 5. That's find function of the domain 5. Well, to do that, it's very simple. Notice what I did here is I replaced the x with the 5. So that's all I have to do. F of 5 equals 4 times 5 minus 7, or 20 minus 7, or 13. Pretty simple on that one. So all you're doing is whatever is inside the parentheses will replace into the x area. Okay, here, you try one. If f of x equals 14 plus 3x, would you find f of 4? And will you find f of negative 7? Pause the recording and try these two problems. Okay, so if we do this, we do f of 4 equals 14 plus 3 times 4, which is 14 times, plus 12, or 26. Here, when we have f of negative 7, that's 14 plus 3 times negative 7, which is 14 plus negative 21, which was negative 7. So, f of 4 is equal to 26, and f of negative 7 is equal to negative 7. How many of you got both those right? Good, I'm glad you did. So that begins our first lesson in our lessons on the function unit. I'll see you tomorrow.